All right, so when we add and subtract, first you have to have a common denominator, then you have to make sure you're only adding the tops, the numerators, and finally you're simplifying. So now, for some examples, I'm going to go ahead and write out the entire example. So there's going to be 5 examples here, and then we're going to go through each one in just a few minutes. If you want to try them on your own first, that's fine. I'm also going to give you some practice problems to try after we do the examples. Now, notice, when I write this out, now this first problem you won't have to multiply anything, but I'm giving a little bit of space between my example number and the actual problem because we will have to write some stuff to the sides of these numbers as well as we do them. So give it a little space after your number. Again, if you didn't space out the first one, that's okay. We really don't have to do anything on that one. It's starting with the second one that we will. Alright, so, there's one thing I just made a mistake on. On number 3, I wanted to make that one a subtraction problem. Sorry about that. Change that one to subtraction. Alright. So those are the examples. Some of you guys are still copying. I'm going to go ahead and write out the try these problems over here, and then I'll go through the examples. Again, if you've already copied all the examples down, you can go ahead and copy these as well. But I will go over the examples first before I do anything else. So we're going to go ahead and go over the examples. I'm going to go ahead and cover the try these because I don't want you to be distracted by copying those right now. So if you didn't get them all, that's fine. We can get them in a minute. All right. But for these example problems, the first one is probably the easiest. All right. If you look at that, do we have common denominator? Yeah, we already have a common denominator. So all we have to do here is start with the second step, adding. So we just add straight across the top. The bottom part stays the same. So we're going to have a 3 on bottom. On top, 1 plus 2, that also gives us 3. Now, can you simplify that? Yeah, 3 divided by 3 is 1. Comes out to a whole number. Now, is every single one of these going to work out to a whole number? No. All right. On the second one, all right, there's a couple different ways you could do this problem. I'm going to go ahead and stick with these steps first, though. So on this one, I'm going to make sure we have a common denominator. Well, this 4, I could make into this 8 through multiplication. Right? What would I have to multiply 4 by in order to make it 8? 2. So we're going to multiply by 2. And if you multiply the bottom number by anything, you also have to do that to the top. So we're multiplying the top by 2 as well. Now, on this one, I only have to multiply one of the values because I'm making it the same as the other one. On most of the rest of these, I'm going to multiply both the fractions by something. All right. But on this one, since I can make that 4, since 4 is a factor of 8, I can go ahead and multiply by 2, and it will become 8. So now, 2 times 2 is 4. 2 times 4 is 8. And on this side, we still have 4 over 8 as well. So 4 over 8 plus 4 over 8. Again, bottom stays the same. 4 plus 4 is 8. And again, this one just so happens to be 1. Again, not going to work out that way every single time. On number 3, this one, you do not have one of the values, one of the denominators being a factor of the other one. So you have a 3 and a 5. Those two numbers don't have anything in common. One of the easiest ways to find a common denominator is just to take the two denominators that you have and multiply them by themselves. So we can multiply the 3 by the 5 and multiply the 5 by the 3. Because in that case, we get the same number, right? 5 times 3 is 15. 5 times 3 is 15. So again, you can just take the denominators and multiply them together, and that will give you a common denominator. Now, will that always give you the smallest one? No. In this case, it does. But in a lot of other scenarios, it might not always give you the least common denominator. And that's okay. Again, I'm looking for a way to make these the same denominator that's easy for every single problem. So again, anything you multiply by on the bottom, again, you do to the top. So on that one, you have to multiply the top by 5. On this one, you have to multiply the top by 3. So now, rewriting this, 5 times 2 is 10. 5 times 3 is 15. On the other fraction, 3 times 1 is 3. 5 times 3 is 15. So now, we're subtracting. Again, when you subtract, it's the same thing as addition. You're just adding negative numbers. So this minus, it's like you're saying plus a negative on the top of your fraction. So I have a positive 10 and negative 3, or you could say 10 minus 3, which gives us what? 7. On the bottom, it stays the same. Can we reduce that at all? No. So not every single one can be simplified. Not every single one is going to give us a whole number as an answer, right? So again, this one just stays as 7 over 15. Now, on number 4, again, what would I want to multiply my first fraction by? 9, yeah. So both the top and bottom and be multiplied by 9. On the second fraction, what am I going to multiply by? 4. So times 4 times 4. And when we do that, 9 times 3 is 27. 4 times 9. 4 times 9, 36, thank you. 4 times 2. And again, 4 times 9 again is also 36. We have the same common denominator. On the top, we're going to have to add them. So the bottom stays the same. The top, 27 plus 8 is 35. Now, we can't actually do anything else with that because those two numbers don't share anything in common. So now, on number 5, same type of thing. What will we multiply the first fraction by? 6. So times 6 on both the bottom and top. On the other side, multiply by 5. So now we end up with 4 times 6 is 24. 5 times 6 is 30. 5 times 2 is 10. And 6 times 5 is 30 again. Now this was a subtraction problem. But again, subtraction is the same thing as adding a negative. So on top, we're combining 24 and negative 10. 24 and negative 10 gives us 14. The 30, that part, again, stays the same. We can simplify. Yeah, so this one we can simplify again, finally. Both of these are divisible by 2. So we can divide both the 14 by 2 and the 30 by 2. So when we do that, we get 7 and 15. That would be our final answer. All right. Go ahead and do those 4 try these. They're similar to the types of problems we just had there. So try those on your own. All right, let's go ahead and take a look at this. Yeah, for the most part, I saw lots of good things. One thing that was a common issue, the simplifying. Make sure you simplify at the end. And the other thing, make sure when you multiply, you're multiplying. If you multiply something to the bottom, you're also doing it to the top. I saw most of you guys did it on like 3 out of the 4 problems, but then a lot of you guys just missed on one problem. You forgot to multiply one of the numbers. So just be careful with that. But let's take a look at the correct answers here. So on this one, didn't have anything to multiply by. So this just ended up being, again, we had 4 on bottom, 4 on top, gave us positive 1 as our final answer. On number 2, we could get both of these to be 10. Some of you guys chose to get both of them to be 50. So there's more than one correct way of doing this problem. All right. Again, this one's kind of like number 2. We had 2 on the examples, that is. We had a number that was a factor of the other denominator. So we could choose to just multiply the first fraction. If you did that, then this would become 4 over 10 plus 3 over 10, which is then 7 over 10. And you don't have to reduce at all. Now, I'm going to put up here the work if you had gone the other way. If you had chose to just multiply the 2 denominators and got 50, it still works. It's just a little bit more work, right? You multiply this side by 10, that side by 5, got 20 over 50 and 15 over 50, which gives you 35 over 50. And then both of them are divisible by 5, which is still 7 over 10. So again, both ways work. It's just if you have the opportunity to only multiply one of them to get the other one, it makes the work a little bit easier. All right. Any questions there? Let me just move that down here in case you need it. All right. For number 3, we have 1/6 and 3/5. Again, multiply the denominators by each other. So this would be multiplied by 5. This would be multiplied by 6. It gives us 5 over 30 plus 18 over 30. So again, bottom is still 30. The top, add to 23, which 23 is a prime number, so there's nothing that can reduce that. So it's just going to stay 23 over 30. The last one is the one that seems to be giving people the most problems. And it might be because we're subtracting, and when we subtracted this one, we got a negative number. So on this one, the beginning on a lot of you guys' papers was good. You did times 2 and times 7. So we had, for the next step, 4 over 14 minus 28 over 14. And again, that was good on the majority of you guys that I saw that got to number 4. You got that part fine. You just have to remember, when you're doing a subtraction, it's like an addition problem. You're just subtracting that top number. So when you're subtracting this, you should get a negative 24. There are a couple of guys that just forgot the negative. Some of you guys that added there instead. So again, just be careful. So this is negative 24 over 14. And then some of you guys just left it there. You could also reduce because both of these are even numbers. 2 goes into both 24 and 14. So if we divide both of those by 2, we should get negative 12 over 7. Now, it doesn't matter if that negative is in the top, out in front, or down in the bottom. That's all the same, as long as there's only one negative sign. So it doesn't matter where you put that negative. All right, like I said, it can be either up here on top of the numerator, it can be out in front of your fraction, or it could be down there with the denominator. And that's all the same thing. All right, you don't want to have 2 negative signs, though. That would not be the same thing. All right, so that's the part on adding and subtracting. The other part is multiplication and division. Now, multiplication and division, I think, is the easier one because you don't have to worry about common denominators. Now, the notes will probably take out the same amount of room this did. So if you think if you've only used half your paper, I'd say just keep going on the same side. If you've used more than half your paper, you might want to do this next part on the back or on a different sheet. I like starting fresh, so I'm going to grab another sheet of paper. But again, it's going to take about the same amount of space that those notes did. So now for multiplying and dividing, again, same title. So if you're still going on the same sheet, you don't have to retitle. This is still fractions. But now, talking about multiply and divide. So you're also going to have 3 steps on this one. Second period. So this time, when you write these steps, leave a little space. So I'm going to put the bullet points here this time. Leave a little space. It's probably going to take more than one line to write the first 2 bullet points. Now, the last bullet point is the same as the last bullet point when we add and subtract. You always want to simplify. Yeah, you always have to simplify. So this last one is going to be the only one that's the same as what we just did. Now, I'm going to do the middle bullet point next because the second step, when we actually multiply, all right, whether you're doing multiplication or division, in the end, you end up multiplying, all right? So the first bullet point I'm going to leave for what happens in our division case. But for any type of multiplying, how do you multiply fractions?
Top to bottom, right? Top to bottom.
What do you mean top to bottom?
Or crisscross?
Not crisscross, all right? So when we multiply, all right, multiplication is different than cross multiplying, right? When you multiply, that means that you have a multiplication symbol in between your 2 fractions. When you cross multiply, that'd be if there's an equal sign between the 2 fractions, all right? So again, if you have proportions, and we'll do a lot of proportions later on in the semester. So we'll talk about cross multiplying. But when we multiply, again, multiplying is different than cross multiplying. And that's one of the most common mistakes. So just be careful. When you multiply fractions, you multiply straight across the top and straight across the bottom. Numerator with numerator, denominator with denominator. So on here, for this second bullet point, we're going to say multiply numerators, which again, that's the top of the fraction. And then multiply denominators, which again is the bottom of the fraction. Oops. Now, the first step I saved for division, because any division problem is really multiplication. Right? How do you divide? When you divide, you actually multiply by a value's what? Anybody know? Starts with an R. Yeah, say it. Reciprocal. So whenever you divide, and it doesn't matter if you're doing fractions or whole numbers. So I wrote this on the board last period over here. Even if I said I was dividing by 2, which most people wouldn't have to look at that as a fraction, right? But even if I was saying I was dividing by 2, yeah, you could do that in your head, that's 3, right? But you could also look at it as multiplication. Instead of saying divide by 2, I could say I'm multiplying by 1/2. Divide is multiplied by 1/2, 6 over 2, which reduces to 3. Any division problem is multiplication. It's just multiplying by a reciprocal. All right, so now, when we do this with fractions, again, we don't have to worry about changing it from a whole number to a reciprocal like that, because a reciprocal, when we multiply a fraction, we're just flipping the fraction that we already have. So I'm going to go ahead and write in this last one. Instead of saying multiply by the reciprocal, I'm going to actually say what we're doing. So if dividing, we're going to change to multiplication. And we do what I like to say is KFC. Keep the first, flip the second, change the sign. All right, so if dividing, change to multiplication. How do we do that? We are going to do KFC, which stands for keep first, flip second, and change sign. All right. So now, we're going to look at a couple examples, just like I did with the examples on the other one. I'm going to go ahead and write them all out first. Now for these, last time I told you to make sure you left space next to the values. On these, I'd actually like you to leave a little more space in between each number, because I'm going to show a couple different ways on some of these to do the problems, because there's more than one way that you can go about multiplying. Again, I'm going to show you using the steps, but I'm also going to show you other things you can do to simplify as you go. And I don't know how much time we're going to have, so I'm going to write out 2 problems for try these over here, but we might not make it to try these during this period. All right. I'm just going to do 2 tries there. Okay, so let me go back up to the top. If you didn't get it, you can get it as we go. For the first example, we have 3 over 2 times 1 over 3. Again, we're just going to multiply straight across the top, straight across the bottom. We don't have to do the first step because this is not division. So we're doing 3 times 1 and 2 times 3. Now, I like showing this step where I'm actually showing it as that's what we're multiplying on top, that's what we're multiplying on bottom for a reason. And I'll go back to it in just a minute. But 3 times 1 is what? And 2 times 3 is 6. Can we simplify it? Yeah. So 3 and 6 both reduce by 3, which gives us 1/2. Now, the reason why I like showing this step, so I'm going to do this problem again from that point on, because when you're dealing with fractions, you can simplify at many different points throughout a problem. You can simplify at the beginning, you can simplify partway through. You can simplify at the end. Now, again, with these 3 basic steps, I'm just showing you follow those 3 steps. You're only simplifying once at the end. But if you want to keep the numbers small, you can simplify as you go a lot of times. Now, with addition and subtraction, it's a little bit harder to do that because you have to have a common denominator. But with multiplication and division, there's several different points you could choose to simplify. You can simplify at the beginning, if possible. You can simplify somewhere in the middle, like right here. We have these 2 sets of values, right? If you have the same factors on both the top and bottom, what would happen to them? So if you have the exact same factor on top and bottom, what would happen to those factors? They can cancel. So here we have 3 on top and a 3 on bottom. We could cancel those off. They'd just be a value of 1 now when you cancel them off. So now we just really have 1 on top and 2 on bottom. And we have our answer. For this problem, it didn't really add any extra work because we didn't have to reduce in the end. We didn't have to simplify it in the end. So we simplified earlier, which let us not simplify in the end. Now, sometimes simplifying in the middle of a problem like this isn't going to actually lessen the work. Sometimes simplifying as we go will actually end up making more work for us. However, there'll be smaller numbers. So it's kind of your choice whether you want to simplify as you go and keep the numbers small, but you might have a little more work, or just do it in so many steps and simplify at the end, so it's shorter, but you'll be dealing with bigger numbers. So again, it's your type of preference there, whichever one you do. So let's go ahead and take a look at the next one. All right. On this one, now we have a division problem. So we have to change this to multiplication. We have to multiply by the reciprocal. So we have 3 over 2. We're keeping the first. We are flipping the second, so that's 3 over 1. And then we're changing the sign to multiplication. So now we are multiplying by the reciprocal. Now this one, there's no reducing that we can do. All right, even if I show it like this, 3 times 3 over 2 times 1, still can't reduce anything. So this one becomes 9 over 2. And again, even the final answer can't be reduced this time. So we just have 9 over 2. That's our final answer. All right. Number 3. Yeah. Same thing. We can go ahead and multiply these straight across. So we'd have 2 times 3. We'd have 4 times 9. 2 times 3 is 6. 4 times 9 is 36. We can reduce those. What goes into both 6 and 36? 6. So divide both 6 and 36 by 6. You end up with just 1 and 6. Now, like I said, that was using our steps, right? We went in the order of our steps. We multiplied it, and then we simplified in the end. However, this is another one where if you chose to do so, you could go a different route. So I'm going to rewrite the same problem. Again, if you don't want to rewrite this, that's fine. We have both of these can be reduced. Right? 2 over 4 can be reduced right at the very beginning. Right? 2 over 4 is the same thing as 1/2. 3 over 9, that can also be reduced. That's the same thing as 1/3. Now if we were to multiply, you'd have 1 times 1 and 2 times 3, which is 1/6. It's the same exact answer. The only difference is we had to simplify twice because we simplified these numbers individually. However, we kept the numbers smaller, so they're easier to multiply. So again, it's a preference. Save the simplifying to the end or simplify at the beginning. Again, in multiplying and dividing, it doesn't matter where you do the simplifying. All right? Again, in the end, you always have to check to make sure it's in the simplest form anyway. With addition and subtraction, it's better just to wait to the end because you have to get a common denominator, and it just gets messy if you don't wait to the end. Yeah, we're almost out of time. Let me do this one problem, and then you guys can pack up. So let's go multiply across the top here. 2 times 9 is 18. 3 times 4, 12. Can we reduce this? Yeah, we can reduce that. Both of those can reduce by 6. So that's 3 over 2. Do we have time for the last one? Let's 13. Yeah, we can squeeze it in. All right. All right, last one. All right. Keep, flip, change. On this one, 4 times 10 is 40. 5 times 2 is 10. 40 divided by 10 is 4. Now, could we have reduced in this one before we got to the end? Yeah, there's all sorts of stuff that we could have done here. We could have reduced the 2 and 10 at the very beginning and just had 1/5. We could have reduced it after we flipped it. We could have reduced somewhere in the middle. So there's lots of places where you could simplify when it comes to multiplication and division. All right, tomorrow we're going to start off with the try these that were on this paper, and then we'll have the worksheet. All right, so tomorrow we'll be doing a lot of practice with this. If you have questions, make sure you ask me as you work on it tomorrow. All right, we got somewhere between 1 and 2 minutes left before the bell. Look at the other sheet. Oh, did anybody need that? I took it down kind of fast. Again, since so many people were out, I'll post these notes as well as the little recording I just did on